We're going to start with sublevel 1 of our Minds on Physics, Newton's Laws modules. And the objectives for this sublevel is that the student should understand the significance of Newton's laws of inertia by identifying and refuting classic misconceptions concerning the causes of motion, and also that the student should recognize inertia as a property of an object which depends solely on the object's mass. All right, inertia is directly proportional to mass. So we need to fill out this sheet so that we could click on that. So click on this right here. When you go to the module, the questions are all in order, and then these sheets are all in order also. The first one says, what is the definition of inertia? All right, so the definition of inertia is that inertia is the property of an object which describes its natural tendency to keep on doing whatever it is it's doing. So it's the property of an object. It's solely depends on the mass of the object, and it is not a force. All right, so inertia and mass are basically the same thing, the same property of matter, but inertia is a term that we see in Newton's first law. If you go down to the next one, Newton's first law of inertia, first law of motion, is that an object will tend to stay at rest, or an object in motion will stay in motion with the same speed and direction unless acted upon by an unbalanced force. All right, so that's Newton's first law of motion, is also known as the law of inertia. So this word inertia means an object's lazy. It refers to the fact that this tendency of an object at rest just to sit there and never move, or an object that's in motion being just continuing in that state of motion at a constant velocity in a straight line, all right, with the same speed and not accelerating in any way. Okay? Let's go to the next one. It says, suppose that an astronaut throws a rock, which is this one right here. Suppose that an astronaut throws a rock in outer space at a location far from significant influence by gravity and air resistance. One would expect that the rock would, and we have here, if there's no forces, it would stay, all right? The motion would stay in the same motion with the same speed and the same direction. So this rock would maintain the same state of motion in outer space. All right, the next one says, when all individual forces acting on an object are balanced, is the natural tendency of an object to, and we go down here and we check what the different answers are, and we see that if the forces are balanced, once again, it's gonna maintain the same state of motion. All right, that's Newton's first law. It's going to keep its constant velocity. It's not going to accelerate. All right, the next one we have, if you move down, we have a sled slides. Keep going down a little bit. Keep going. All right, keep going. A sled slides down a hill, reaches the level surface, and eventually comes to a stop. The fact that the sled ultimately stops, why? Why does something stop moving? Because of friction. So Newton's first law says an object will maintain its state in motion unless acted upon by an outside force. And what we're learning about is friction is a force that acts on objects and changes its velocity to decelerate or to lose velocity and then eventually stop. So if something comes to a stop, it's not because it's maintaining its state of motion. It's because there's a force acting on it, which is called friction, that brings it to a stop or slows it down. Okay? The law of inertia applies to any object that has mass. All right? So all matter obeys the law of inertia. All matter. So all matter has mass and volume, and anything with mass that is a physical object obeys the law of inertia. Mac and Tosh are arguing in cafeteria. Tosh says that if he flings Jell-O with a great speed, it'll have greater inertia. Mac argues that inertia does not depend upon the speed, but rather upon the mass. Who is correct? Mac, because what?
Oh, no, I got a low battery warning.
Okay, so Mac is correct because Mac knows that Inertia depends on matter only matter, not speed, not acceleration, or any of these things, just matter, okay? Turn the page here, it says, when will an object have inertia? Right? It'll have, if it has mass, it has inertia. So all objects have inertia. So if it's at rest, it stays at rest. If it's in motion, it wants to maintain that state of motion unless acted upon by an outside force. And then we have a velocity here. We have our velocity of our cars. I don't know if you can get this. All right, we have 1 kilogram, 2 kilogram, 3 kilogram, 4 kilogram. We have 4 meters per second for the 1 kilogram, 3 meters for the 2, 1.5 meters per second for the 3, and 1 meter per second for the 4 kilogram. Which one has the greatest inertia? Why?
Because it has the greatest mass.
It has the greatest mass. So speed really has nothing to do with inertia. Inertia is based solely upon the direct relationship to how much mass. The object with the greatest mass has the greatest inertia. We have the same problem here, and we're talking about forces. We have acceleration, mass times acceleration. Which object has the greatest inertia in an acceleration and mass and force problem? Which one of those 4 objects has the greatest? Why?
Because it's got the greatest mass.
Because once again, it's got the greatest mass. And although there's different ways to look at how the problem's asked, it's always only concerned with which object has the greatest mass, has the greatest inertia, and which object has the least mass, has the least inertia. Okay? So that's all you need to do to be successful in submodule, sublevel number 1 of Minds on Physics, Newton's Laws modules.